Good morning, everyone. I'm Eugene from NeuStar, and today I'm going to talk to you a little bit about VoIP. In today's world, VoIP has finally come to pass now where it's had two basically false starts, and with the evolution of the technology, anyone can be a VoIP operator, or basically everyone is in a way a virtual phone company. Borrowing from Cisco, the structure is that the internet, or basically any IP infrastructure, becomes the virtual phone company. A little quick history about VoIP protocols. H.323, which was back in the mid-90s or so, which a lot of people actually were used for video conferencing, was the original protocol that a lot of people used for VoIP. Then moved on to MGCP that the cable industry used for a while. Then SIP, and most recently the IETF and the ITU collaborated to come up with H.248. Some issues that I wanted to talk to you all today about is some issues that regarding VoIP and that affects peering and some other issues in general about the whole idea of running VoIP. Latency, jitter, out of order delivery, packet loss, ENUM, security, SPIT, and PSTN on-off ramps. Latency is more of an issue, of course, with voice, because unlike a data session where you're browsing or surfing the internet, if packets arrive above a certain latency, you and I can detect it. We hear it. Or unlike when you're browsing the internet, it doesn't affect you as much. The ideal should be about 150 millisecond on one-way latency, but a round trip of 250 or lower is the best. The ITU recommends 150 millisecond or less as the tolerable latency. And for those of you that remember the old satellite, long-distance service satellite business systems, a lot of complaints that people that remember them was that the long delay time there made the conversation very awkward to have. The components that make up latency are network, the codec, and jitter buffers. Jitter and out-of-order delivery. As some friends of mine in the industry have pointed out, that there's a difference between jitter and out-of-order. Jitter is basically the variability in the loss in latency. Out-of-order delivery is the portion of the packets that arrive later than others and out of sequence. That resequencing causes severe problems. For those of you that don't know, there's something called MOS scores, or stands for mean opinion scores. It's not a very strict scientific way of measuring what is considered acceptable. It's basically rated on a scale from 1 to 5, 5 being highest, 1 being lowest. It's kind of a subjective evaluation of what people perceive to be acceptable voice quality over voice over IP. And in this chart, you'll see that we've ranked the different types of popular codecs that are being used today, and they're ranked basically by MOS scores, by delays, in terms of latency by the codec on the right-hand side. There's G.711 at the very top that has only a 0.75 millisecond delay that's introduced by the codec itself, but its bit rate that's required to operate at is at 64K, where at the very bottom you've got the G.723, but it introduces a delay of 30 milliseconds. And the MOS scores, of course, are down at 3.65. The lowest MOS score on this chart, of course, is the G729 times 3 encodings, where it crosses over several G729 codecs. This chart was meant to, just as an example, to show what happens when you use different codecs. The colors for the other variables, the network delay, the queuing delay, and the jitter effect, were all held at a constant, and it was only the codec latency that was the variable number to show the significant difference that the type of codec used can affect the latency considerably. in our experience, we're finding that pretty much G711 and G729 seem to be the codecs of choice today. Depending on who you talk to, people feel that 711, of course, is the way to go, but based on the previous slide, as you saw, 711 has some technical issues that causes requirements that may or may not be able to be met, or some people feel that it's just not worth the cost. So in terms of packet loss, just segueing from the codec issue, the 711, of course, is less tolerant to 729 for packet loss because of the higher bit rate requirement. So what is acceptable? As we all know, 1 to 3% is about the norm for packet loss. There could be academic arguments about higher or lower and so on. It'll probably work for 729. May not work for 711. Again, this is a argument that could be argued that it would work for 711, and some people say it will not work. Less than 1%, of course, would work for 711, but that's probably an unrealistic number to be striving for. ENUM. For those of you, just a quick primer on ENUM. ENUM is basically a directory service, very simply. It basically takes a phone number. In this example, one of my coworkers, his phone number, the country code, the area code, and phone number turns into a fully qualified domain name, which is basically E164 ARPA definition, asks the DNS, and basically returns the URI, and in this case, it's a SIP address. Want to give you a quick overview of ENUM call flow. So basically, the person calls the phone number because no one's going to be dialing people on voice by typing in SIP addresses. They're going to basically just follow conventional standard phone numbers, and basically they'll hit a SIP proxy at that point, which they will basically do an ENUM lookup, and ENUM basically does the corresponding translation, and the SIP then knows where to basically direct the call. Something I want to briefly touch on is public ENUM. Public ENUM, there are two types of ENUM that's basically being worked on today, just public ENUM and private ENUM. I want to talk first about public ENUM. Public ENUM is assumed to be an opt-in service, and without going through all the gory detail on this slide here, basically this is still a very tenuous effort underway. There's a lot of differences of opinion. Different governments have different opinions. There are privacy issues, policy issues, and even from carriers to carriers, corporations to corporations. And the net sum of this is that at the very end point, consumer enterprise adoption is a question mark. And I'm going to get to that in the next slide or two. But while ENUM today is still a industry geek thing, it's not going to stay that way simply because it has to be dealt with for VoIP to succeed. A new concept is private carrier infrastructure ENUM. We're finding that a lot of corporations and individuals, or basically non-public ENUM, is sprouting up. It's a good example would be an enterprise or a non-carrier corporation has started to implement voice over IP for all their internal calling, or a good portion of their internal calling. Well, they need to have some directory to figure out where do they route these calls, and is it one of their internal calls? Is it an IP endpoint? And again, similar to the public, there are a lot of unanswered questions here with ENUM. The technology could be a pull model or a push model. The thing that we want to leave you here with is that both private and public are orthogonal to each other. They have their places and they serve different purposes. In fact, it's our view that there's probably going to be some hybrid of the two in the future. It's our belief that private ENUM will be implemented before public ENUM. In fact, it's factual that it's already happening. We know of many companies that have already implemented variations of private ENUM, and public ENUM is still being worked through the different governments, both in North America and all over the world, as well as within government regulatory environments. Enterprises are already creating their private enums. The concern here that I think we all should have is that islands are being created. And once islands are created, then how do you get from one island to another? These are all questions that need to be resolved and worked on by the industry as a whole. Lastly, there is the issue about, unlike DNS, the issue about who is the authoritative enum, who is the root, basically, or who are the roots. That has not been answered. Security is another issue with voice over IP. There's SPIT, of course, which I don't know. When I ran this presentation by our internal legal folks for compliance and marketing people, they were asking, like, what is SPIT? And I said, well, it's basically spam, except for voice over IP, spam over internet telephony. Another issue that is of concern is about trust between domains, where in the peering world, we can have domains basically peering with each other. In this case, this example of this slide, network A and network B may trust each other, and network B and network C may trust each other, but A and C may not trust each other. On the next slide here, some people have started implementing session border controls, which is what the SBC stands for. So the SBCs are very good at establishing trust between two domains, but using the previous example, you may have SBCs implemented between network A and network B, and between network B and network C to establish the trust, but because of the way the domain peering can work, it doesn't stop the traffic from flowing from network A to network C. So in terms of differentiation, one thing about VoIP that introduces something new or relatively new, depending on your perspective, that you often have new applications that are sensitive to what I mentioned earlier about latency and basically quality of service issues. So you have basically, for lack of a better term, not necessarily quality of service needs, but quality needs. People will say that you do not need quality service from end to end, from point to point, but only for certain sections to establish a quality session. And this is an argument up for debate. And in terms of private peering, if for voice or other SIP-based applications to be going across, say, transit instead of direct private peering connections, what's that going to do to your connection? It's basically an unknown variable. It could be fine in 99% of the time, and the 1% of the time it could be horrible, or somewhere in between. It's all different possibilities. Lastly, security. Those two security issues that I mentioned, those were just two examples. There are gazillion security issues that the voice over IP as well as SIP has not dealt with. Just wrapping up on the future. 2004, something that was very interesting fact that we found from Avaya and Nortel, that they basically said that in 2004 their shipments of IP-based PBXs actually exceeded their traditional TDM-based PBX shipments. That's a fundamental shift. In fact, when we spoke with the Avaya folks, that they were surprised, at least from the marketing and sales perspective, that the IP PBXs had actually surpassed TDM. The governments are having a Sybil complex, referring to that movie about people that are having multiple personalities. They're having different agendas, different conflicting directions being tasked upon them as well as themselves. Law enforcement is being involved. CALEA, for those of you who don't know what CALEA is basically the ability for law enforcement. In the United States, it's the FBI, and in Canada, it's the RCMP, where they basically will come in and basically ask that they need to wiretap, equivalent to the analog TDM voice world, where they need to find out who's talking to who, what's being said. Well, that whole game changes in the IP world. Homeland Security is also part of this issue. And of course, there are conflicting interests between CLECs, ILECs, MSOs, PPTs, ISPs, and content providers. Issues and challenges, it's basically just more of the same, and the technology is evolving. And that's basically my presentation, and I'm not sure about time, Susan. Okay, so any questions? Okay, well, thank you.